So remember tonight, so I graded your first homework assignment, the one that was from P2 and P3. The grades are in the Dropbox. So if you go to the Dropbox, there's my reply to your so graded assignments. Or in Dropbox. So there's a reply that I made to your assignment that you should be able to see, and it has your score on it. So this one is out of 15 points, this first assignment that we had. And then the solutions, I'll be posting the solutions to the homework assignments here on the website. So here's the P2 and P3. All right, so here's the solution. So there was, these problems, 48, 52, 60, 32, A, B, and C, and then 36. I actually didn't grade 36. But this was 2 points, 2 points, 2 points, 3, 3, and 3. So
Can you share your screen?
Oh, I'm sorry. I'm not sharing my screen. That was bad. So on the website, here's the website, right? And homework solutions are here, right? So, on the P2, P3 assignment, there's 48, 52, and 60, 2 points each, and here's the solution. In P3, there's, these 32, A, B, and C, 3 points each, and 36 I didn't grade. So in the Dropbox, in the reply to your assignment, I'll have written like 2, 1, 2, 3, 0, 3 or something. So that's the number of points you got of each problem. Okay. Did anyone see that, or anyone have trouble seeing that? Anyone have trouble seeing that information?
No.
Right. I think I made the folder invisible inadvertently, but I fixed that, so you should be able to see it now. Chase. Okay.
Okay, thank you.
Yeah. Alrighty. And here's the next assignment for P7. So, basically going with, a couple problems for each section. And I will post the solutions each time. The one for P4 is due tonight. And I'll grade those as quickly as I can. With the solutions online. And these problems will be very much like what I'm going to ask on the exam. I mean, of course, I'm not going to ask that many questions on the exam. But exam problems will essentially be things very similar to these things that you're handing in. Okay. So the first web assignment that's due tonight, and the second one that'll be due on Monday. And the first exam is going to cover P2 to P8 and sections 1.1 to 1.4. So we're not, really close to having completed that material, but we're getting there, and I'll announce the date of the exam a week ahead of time. Okay. Alrighty. So let's get back to P6. We were talking about factoring. So we talked about factoring a quadratic polynomial. So a quadratic polynomial is a polynomial with an x squared term, an x term, and a constant term. All right, and we looked at all the different ins and outs of that. And, someone asked the nice question before, do these things always factor? And the answer is they almost never factor. Now, in the book, every problem they ask you to factor does factor. But, I mean, if you just take a random quadratic polynomial and you ask, does it factor? you know, most all of the time, no. Although they can have solutions, and we'll talk about how you solve, quadratic equations later. All right. So now, I'm sorry. And then there's quadratic polynomials where the first coefficient here is not 1. So if the first coefficient of the quadratic polynomial is not 1, then, there are more possibilities to consider. And I wrote out what that looks like right at the beginning. So let's go grab that. So, if you have this polynomial ax squared plus bx plus c, where a isn't 1, if it does factor, which again the answer is, for a random polynomial, probably not. But in the book, when they ask you to factor it, it will factor. It'll look like this, but the coefficients of the x's here aren't always 1. And then if you have these two factors, p1x plus p2, q1x plus q2, and you multiply it out, then you get this here. And the p1, q1 is equal to a. If they're the same, p1, q1 should be a, and p2, q2 should be c. And then this, you just kind of have to muddle through all the possibilities to see which one works. So there's many more possibilities than before, but it's still manageable. So some examples. So 2x squared minus x minus 1. All right, well, 2 is equal to 2 times 1, and 1 is equal to 1 times 1. Right? 2 is equal to 2 times 1, and 1 is just equal to 1 times 1 in terms of integers. And then this is a negative here. Right? So if it's going to factor, it's going to look like this. 2x, 1, x, 1. Right? If it factors, it must look like this. Okay, so now the question is, and one of these has to be positive and one has to be negative. So, make those red. One positive, one negative. So if it's going to factor, it's gonna go like this. Well, just muddle through the possibilities and see which one it is. 2x plus 1 times x minus 1 is equal to, well, 2x squared plus x minus 2x minus 1. So that's 2x squared minus x minus 1. So that's the right one. Right? If you tried the other way, 2x minus 1 times x plus 1, well, what would you get? 2x squared minus x plus 2x minus 1, which is 2x squared plus x minus 1. So this is not the right one. Right. So the answer is 2x squared minus x minus 1, 2x minus or plus 1x minus 1. How about this one? 9x squared plus 9x plus 2. All right, well, you know, there's different possibilities here, right? The 9 is equal to 9 times 1. It's also equal to 3 times 3. And then this is a positive 2, and this is a positive 9. Okay, so positive 2 and positive 9. So 2 is going to be equal to 2 times 1. Well, it's going to be equal to positive 2 times positive 1 rather than negative 2 times negative 1. Right? So the only possibilities here are, well, which ones are there? There's 9x plus 2 x plus 1, right? So 9 times 1 is 9, 2 times 1 is 2. And these have to both be pluses or both minuses because that's positive. But then because this is positive, they have to both be positive. 9x plus 1, x plus 2. And then 3x plus 1, 3x plus 2. Those are the only possibilities. Right? 9 and 1 here with 2 and 1 there. 9 and 1 here with 1 and 2 here. Or 3 and 3 with 1 and 2. Well, which one is it? Which one gives you the right middle term? Right? Which one gives you the right middle term? Which one gives you 9x? How many x's does this one give you?
2.
Well, 2x here for the inside terms, and for the outside terms, 9. Right? So this is going to be 11x. So that ain't it. This one is going to give you x plus 2x. Or sorry, x plus 18x. So that's going to give you 19x. So that's not it. And this one's going to give you 3x plus 6x, which is 9x. All right, so if you multiply the outside terms of the two factors and the inside terms, those are the x terms. All right, it is 11x, 19x, and 9x. So this is not it, this is not it, it's this one. 3x plus 1, 3x plus 2. So also, by the way, if you had 9x squared plus bx plus 2, 9x squared plus bx plus 2, the only times that factors is when b is 11, 19, or 9. Any other number, it won't factor. In terms of integers, it won't factor over the integers. It factors in more complicated ways, which we don't want to necessarily discuss. All right. So now that we know how to factor quadratic polynomials, that can be used to factor a greater number of polynomials. You know, just based on that factoring technique. So this degree 3 polynomial has a common factor of 2x in each term. So 2x to the third minus 2x squared minus 12x. You could even, yeah, that's fine. All right, there's a common factor of 2x in each term. So factor out the 2x. And go from there to try to factor the polynomial. Into more factors. So 2x to the third minus 2x squared minus 12x. I factor out the 2x, and what's left here is x squared. Right? 2x times x squared is 2x to the third. What's left here in this factor is minus x. 2x times minus x is minus x squared. And then here, 12x, factoring out the 2x, leaves me with what? In the third term.
-6.
Negative 6. All right, and now here's just a plain quadratic polynomial. You know. Might factor more. Okay, well, this one, 6, is 6 times 1 or 2 times 3. Right, and the leading coefficient there is 1. The coefficient of the x squared is 1. And then you're going to have 2 and 3. One has to be positive, the other has to be negative. Right, so minus 2 plus 3, minus 2 plus 3 will give me minus 2x plus 3x. That's plus x. So that's not it. So it must be x plus 2, x minus 3. And that's the best you can do. So that would be a final answer. So this is fully factored now. Okay. Another example like this. So another polynomial with a common factor in each term. So suppose we had x to the 9, hold on a second. Yeah, x to the 9 halves minus x to the 5 halves. Let's say minus 4 x to the 5 halves. Okay, the lowest power of x in all those terms is x to the 5 halves. So lowest power of x right? So I'm going to factor out that lowest power of x, x to the 5 halves. All right, so now what's left over here from the x to the 9 halves?
X to the 4 halves.
X to the 4 halves, of course, which is 2. We'll get to that in a moment. So that's x to the 5 halves, and then x squared minus a 4. And then this quadratic polynomial here is that special difference of two perfect squares. Difference meaning subtraction. Right? A plus b times a minus b is equal to a squared minus b squared. So that's a, a special factorization that crops up every so often that, one should keep in mind. So this one is x plus 2, x minus 2. So x to the 5 halves, x plus 2, x minus 2. And this can't factor any more than that, so this is fully factored now. Okay. Here is here is a really rare example for degree 3 polynomials. So grouping terms with degree 3 polynomials works in very rare instances. I mean, it's funny when I say very rare, because, like, I mean, all the problems in the book are these rare instances, when these things just happen to work. But anyway, it stands talking about because it's just there. So 9x to the third plus 9x squared minus 16x minus 16. So what I mean by grouping for this degree 3 polynomial, by degree 3 I mean, of course, the highest power of x is 3 in this polynomial. Take the two highest power terms, that's the third power and the second power, and then take the two lower power terms like that. Okay, so I factored out a negative there. Well, let me not do that. Let's just do it this way. Plus minus 16x minus 16. Within these two terms, there's a common factor, lowest power of x squared, right? Within these two terms. X squared is the lowest power of x. So let's just factor that out. And here we're left with 9x plus 9. So actually, there's a common factor of 9 as well, so let's take that out. So 9x squared, and here we're just left with x plus 1. Here, there's a common factor of negative 16. And now I'm left with x plus 1. So here's the miracle that rarely occurs, is that, again, I have a common factor. Of x plus 1. I have two terms here. I got term 1, term 2. And within term 1 and term 2, I have x plus 1 in these two terms. So I can pull that out. X plus 1, 9x squared minus 16. Okay, and then, this might factor some more. This is a difference of two perfect squares. So if it does factor more, it'll be because this is a difference of two perfect squares. Difference of two squares factors more. So this is equal to x plus 1. And then this is 3x squared. So this is 3x minus 4. 16 is 4 squared. And 3x plus 4. And that's fully factored. Now, it doesn't have to be that, this last bit factors some more. It might not. Okay, but this grouping technique, it sometimes works. It works in the instance that when you group these two terms and pull out the common factor, and you're left with, something x squared times this thing here. And over here, if you pull out the common factor, and here we're left with minus 16 times x plus 1. Because this x plus 1 is in both terms, I can pull it out. Okay. So that doesn't happen too often, but when it does happen, it does. And there it is. So that's pretty much, everything that we're going to discuss in terms of factoring here. There's definitely more that can be talked about, and that you would do in your pre-calculus class, which is the 1350. So, but that's the basics of it. Alrighty, let us move on to section P7, which is on rational expressions. So remember, an algebraic expression was the sum and difference of monomials, typically of one variable, x, right? An algebraic expression is a sum of monomials. Alright, so for example, like this whole section that we just finished, P6, we were talking about algebraic expressions. They were the polynomial sort, where all the exponents were integers, but, they don't have to be. X to the third minus 6x squared plus 3 plus x to the negative 1, right, or x squared, x to the 2/3 minus x to the 5/3 plus x to the 1/2 plus 8. Right, so an algebraic expression is a sum of monomials. When the exponents are all positive integers, it's a polynomial. Integers, the algebraic expression is called a polynomial. Right, so all polynomials are algebraic expressions, but not all algebraic expressions are polynomials. Right, that kind of thing. A rational expression is a fraction of two algebraic expressions. Right, so x plus 1 over 3x squared plus x minus 5, or x plus 1, x plus 2 over x, or 1 over x minus x squared minus x minus 6, so on and so forth. So a fraction typically of polynomials, but they could just be general algebraic expressions. Okay, that's a rational expression. So a rational expression is simplified when either the numerator and denominator are fully factored or in standard form. All right, so our fully an algebraic expression is simplified when the numerators and denominators are fully factored. Let me think. Fully factored or in standard form without negative exponents. No, I guess we can sometimes have those. Without common factors in the numerator and denominator. Fully factored or in standard form without common factors in the numerator and denominator. Yeah, that would be it. So, there's different, tasks that you would need to do in order to work with rational expressions. So when working with rational expressions, common tasks would be to 1. Add or subtract the expression, 2 expressions, and then simplify. Or resolve any nested fractions and then simplify. What I mean by nested fractions, I mean like this. If you have a fraction a over b over c over d, right? A fraction divided by a fraction, this is equal to a over b times the reciprocal of this guy, d over c. Right? Add or subtract or multiply, I'm sorry. So here, this is a nested fraction. A over b over c over d is a over b times d over c, right? Or something like this, a over b over just the c like that. That's going to be equal to a over b c. Or something like this, a over b over c like that. Is going to be equal to AC over B. Okay, so nested fractions come in different varieties. Like a fraction over a fraction, or a fraction over, some other just expression like that. And they all simplify in these various ways. Okay, well, these two are actually specializations of that, because c by itself can always be written as c over 1. Right? That can always be made a fraction by doing that. Same thing over here. The a can be made a fraction by doing this. So let's take a look at some examples of that. So subtract and then simplify. Subtract and then simplify. So if I had something like this, 1 over x squared minus 1 minus the rational expression 2 over x plus 1 times x plus 2. I want to add these two guys or subtract these two guys and then simplify. Okay, before I can add or subtract two fractions, I need what? I need a common denominator. Right? I need a least common denominator of some sort. Right? This denominator here and this denominator here, they're different. Okay, so I can't just subtract them right away. So remember, adding fractions, adding and subtracting fractions first requires a common denominator. So in order to do that, the first thing I'm going to have to do is to fully factor the denominators of both fractions. So this fraction is already factored in the denominator. This one, well, that's a difference of two perfect squares. So that becomes x minus 1, x plus 1, minus 2 over x plus 1, x plus 2. All right. I have common factors in these denominators of x plus 1. So these are now fully factored. And I have common factors of x plus 1 in both. Right? But that's not a common denominator. A common denominator would have the exact same factors in both. So that's what I want to get. Fix this a little bit so I can fit it on one line. How do I do that? Well, I would do that as follows. So this first fraction, right, I have three different factors here. I have the x minus 1, I have the x plus 1, and I got the x plus 2. I've already got an x plus 1 in this denominator here, right? But I don't have the x plus 2. So there's three factors in total here. Three different factors. All right, there's three different ones there. I've already got the x plus 1 in both, but I have an x plus 2 here, and I don't have an x plus 2 here. So I can put it in there by multiplying this by 1. Same thing with this second one. This is not going to fit here. Let's see. And this one is 2 over x plus 1, x plus 2. And then I'm missing the factor of x minus 1. Right? So nothing changed here because this is equal to 1 and this is equal to 1. And multiplying by 1 doesn't change anything. Right? It doesn't change a quantity. So this quantity here is the same as this quantity here because, right, this quantity is multiplied by 1, so it remains unchanged. And this second quantity here is multiplied by 1 over here, so it doesn't change, right? When you multiply by 1, things don't change. So I'm definitely still equal. All right, so let's multiply these two fractions together and see what we get. I have x plus 2 over x minus 1, x plus 1, x plus 2, minus 2 times x minus 1. By the way, when you multiply a times a plus b, or b plus c, or something like that, when I want to multiply these two things together, I have to put a parentheses around the multiple term factor. Right? I can't write 2x minus 1. Right? I can't write 2x minus 1. I've multiplied the x by 2. That's multiplying x by 2. I need to multiply 2 by x minus 1. So that requires a parentheses there. Common mistake. And then I've got the same denominator here. X minus 1, x plus 1, x plus 2. Right? So I have the same denominators in these two fractions. So now I can subtract them. So I have x plus 2 minus 2 times x minus 1 over x minus 1, x plus 1, x plus 2. Now let's simplify the top here. Right? How would I simplify the top? On the top, I've got an algebraic expression, or a polynomial in this case. Right? What do I need to do to simplify that? I need to write it as a sum of monomials with all the powers of x different in each term. Okay, so I need to multiply the 2 through here. And then collect like powers of x. So I have x minus 2x. X minus 2x gives me a negative x, and then 2 plus 2 is 4. X minus 1, x plus 1, x plus 2. All right, and that is a rational expression whose top and bottom are in fully factored form. Okay, this one here, of course, it's not going to factor any more than just what it is by itself. So it's just one factor on its own. And on the bottom, we're fully factored. So you can have the top and bottom fully factored, or the top and bottom in standard form, as long as you don't have any common factors, which we don't. Okay, so let's go over that again. I want to subtract these two rational expressions and then simplify. Okay, so I have 1 over x squared minus 1 minus 2 over x plus 1, x plus 2. In order to add or subtract two fractions, I need a common denominator. I need the denominators to be the same. In order to find a common denominator, first we need to factor the denominators fully in both fractions. So the x squared minus 1 is 1 over x minus 1, x plus 1. And this one was already factored. Okay, so I have three different factors here. X minus 1, x plus 1, x plus 1, and x plus 2. All right, this one is missing the x plus 2. This one is missing the x minus 1. How do we insert it in there? Well, you multiply each fraction by 1, where by 1 I mean the missing factor over the missing factor, right? I mean, this is a fraction where the denominator and numerator are the same, so of course that's just equal to 1, because anything divided by itself is 1. So this is x plus 2 over x plus 2, x minus 1 over x minus 1. Multiplied these fractions together, these two fractions together, and that's what I get. And now the denominator in both fractions is x minus 1, x plus 1, x plus 2. So now I can subtract. Right? Numerator minus numerator over that common denominator. Simplify the algebraic expression or the polynomial on the top, and I got minus x plus 4. At this point, you may have some common factors that are going to cancel, but not in this case. We don't have them. Okay. How about the nested fractions business? Well, let's try another example. Okay, subtract and simplify the two rational expressions. So x over x squared plus x minus 2 minus 2 over x squared minus 5x plus 4. So before I can subtract two fractions, I need a common denominator. Okay, in order to get a common denominator, first we must factor fully the denominators in both rational expressions here. This one, well, there's a negative 2 here. All right, so this is going to be x, 2, and 1. It's a negative 2. So one of these is negative and one of these is positive. So it's x plus 2 or x minus 2. And then you get the corresponding x plus 1 or x minus 1. Well, which is it going to be? Where's the plus going to go? Is it this one? Or is it the other one? Well, check the inside and outside terms, right? This is minus 2x plus x. Minus 2x plus x gives me minus x, but that's not what I want. I want plus x. So it's got to be the other way around. All right, so I've factored that one. The second one, so I have x squared minus 5x plus 4. Well, 4 is 4 times 1 or 2 times 2. This is a positive, right? So it's either minus 4 minus 1. Right? It's either minus 4 minus 1, or it's x minus 2, x minus 2, right? Because this is negative. That's positive and this is negative. So it's going to be minus 4 minus 1 or minus 2 minus 2. Which one is it? Minus 4 minus 1 or minus 2 minus 2? Which one is it?
Minus 4 minus 1.
Minus 4 minus 1. Multiply the outside and the inside terms. This is minus 4x minus x. All right, minus 4x minus x is minus 5x. Here you get minus 2x minus 2x, which is minus 4x. Right? I want minus 5x. So it's this one. Oops, shouldn't have erased that. X minus 4, x minus 1. Okay, again, I've got 3 different factors here, right? I've got x plus 2, x minus 1, there's the x minus 1 again, and x minus 4. So in order to get a common denominator, I need all three of those factors in the denominator of both fractions. So let's do that. So this is going to get multiplied by x minus 4 over x minus 4, because x minus 4 is the missing factor in this denominator. Minus 2 over x minus 4, x minus 1, and this one is missing the x plus 2. So this gets multiplied by x plus 2 over x minus 2. And again, that doesn't change the value of the expression because we're just multiplying by 1. Okay, so now multiply these fractions together. By the way, when I'm multiplying x by x minus 4, I need a parentheses here. I'm multiplying x by the entirety of x minus 4. On the bottom here as well, x plus 2, x minus 1, x minus 4, minus 2 times x plus 2 over x minus 4, x minus 1, x plus 2. All right? So now I have a common denominator, so I can subtract the numerators. So x times x minus 4 minus 2 times x plus 2 over x plus 2, x minus 1, x minus 4. And now we need to simplify the numerator. The denominator is fine. The denominator is fully factored. That's all good to go. But we need to simplify the numerator here. So first, let's get it into standard form. Multiply this through, and you get x squared minus 4x. This is minus 2x minus 4 over x plus 2, x minus 1, x minus 4. Still going. X squared minus 6x minus 4 over x plus 2, x minus 1, x minus 4. Okay? Does this factor? Does the numerator factor? So, I mean, the numerator is in standard form, but there may be still some common factors on the top and the bottom. So in order to find those common factors on the top and the bottom, I would need to factor the top. All right, but let's check that out, right? Negative 4 is, right, negative 4 times positive 1, or positive 4 times negative 1, or negative 2 times positive 2. Okay, but x minus 2, let's do it over here. X minus 2 times x plus 2, well, that's the difference of two perfect squares business, is x squared minus 4. X minus 4x plus 1, if you work it out, is x squared minus 3x minus 4. And x plus 4x minus 1, it's x squared plus 3x minus 4. Right, so the numerator over here doesn't factor. So there can, since it doesn't factor, there can't be any common factors on the top and the bottom. Okay, so there it is. The numerator is in standard form. Denominator is fully factored. So that's all she wrote. Okay, it could have been that I could have factored the top and some factor on the top and the bottom would cancel, but it didn't happen. Okay. 10:47. Ah, good. More time to go. So here's an example. Oh, sorry, is there any questions about that one that we just did? Is anyone seeing any part of this or the other one that they're not understanding? Again, guys, please speak freely. I mean, if you're confused on a step, then let me know. Please speak and not use the chat. Okay, well, in that case, we're going to need some extra time. Okay, I mean, again, it's a matter of practice and a matter of repetition. So, one way you can get started on that, if you don't know where to start at all, is to redo these examples I just did. Okay, so start with this example right here and work that one out on your own, or start with this one over here and work it out on your own, and without looking at my answer, and then check your work against mine. If not, then, if even that's not working, I mean, look carefully at how this one is done, and then try to do that one. And then get to work on the, discussion problems in the text. I mean, if you're still having problems, then, you need to make an appointment to come and see me. I have office hours now, Tuesdays and Wednesdays, in my WebEx room, so we can meet there if you don't want to make a specific appointment. I sent the link for that. I'll send it again after class. So let's do an example of simplifying a nested fraction. So let's have x squared plus 2x plus 1 over x minus 2 over x plus 1, x squared plus x minus 6. All right, so again, whenever you have fraction a over b over c over d, that's arithmetically equal to a over b times the reciprocal of the fraction on the bottom, d over c. So this one here becomes x squared plus 2x plus 1 over x minus 2. And this one is x squared plus x minus 6 over x plus 1. So we flip the fraction on the bottom upside down and multiply it by the top fraction. All right, well, you multiply two fractions together just by multiplying the numerators and denominators together. Now, the only issue here is that there might be common factors on the top and on the bottom. So in order to find out, I need to fully factor the top and fully factor the bottom, and then cancel common factors. So on the top, this one factors as x plus 1 times x plus 1, and this one factors as x plus 3, x minus 2, over x minus 2, x plus 1. Okay? So, okay, we're fully factored on the top and the bottom. And I have common factors. I got x plus 1 here and an x plus 1 here. When you're fully factored on the top and bottom, you can do the cancellations and combine, identical factors. This would be x plus 1 squared, but we need to cancel anyway, so we don't need to combine those. And then here's an x minus 2, and there's an x minus 2. And therefore, I'm left with x plus 1 times x plus 3 over, and what's on the bottom, since I canceled both? What's left on the bottom?
1.
Just a 1. When you've canceled out all factors on the top or on the bottom, what's left is not 0, but a 1. Right, because 1 is the multiplication identity. Right, I mean, if you're have a factorization of some number and you want to pull away all those factors, what's left has to be the multiplication identity, which is 1, not 0. 0 is the additive identity. When you cancel out terms additively, then you get 0. But anyway, you don't want to leave it like that. You want to write it like this. All right, so there's your final answer there. All right, so whenever you get a rational expression, so I mean you have subtracting and adding two rational expressions or resolving a nested fraction, when you get it down to, a rational expression over a algebraic expression over an algebraic expression, just as one run fraction, then you might have common factors on the top and the bottom. So you need to fully factor the top, fully factor the bottom. This one's already fully factored on the bottom. And then cancel out common factors, if there are any. If not, then there aren't. So that's what we get in the end there. One warning. So you can't cancel factors in a fraction that isn't factored fully. You can't cancel common factors in a fraction that's not factored first. So you need to factor it first, then you can start doing some cancellations. Okay, if it's not factored, then you can't. So, for example, what I'm talking about here, so I mean, if you have like x squared plus x to the third over x squared times x plus 1, something like that, you can't do any cancellations here. Can't cancel any factors yet. First, you need to factor fully. Well, this one, you get a common factor of x squared on the top. And then you're left with x plus 1. And on the bottom, you got x plus 1. And then, all the factors cancel out fully. You're just left with 1. Okay? So, maybe that's kind of a cheesy example. Just made that up off the top of my head. X plus 1 over x plus 2. So here you can cancel the x squareds because we're fully factored, and you're left with x plus 1 over x plus 2. But you can't do anything with this yet. First, factor fully. That's a really, really, really common error. Okay? I see that a lot. Okay? One, in calculus, like in subsequent courses. So like when students are in calculus and they're dealing with rational expressions, they'll do something like this, which is just not valid. You can't work with you can't cancel common factors in a rational expression that's not first factored fully. Okay, so really, really common error. So try to avoid that. I'm drawing your attention to it. Okay. All right, guys. So I'm gonna be in my WebEx room at 11:30 till 12:30. If you want to just drop in there. If you need more time, we can arrange more time. Or if you can't make it at that time, we can arrange a different time. Okay. But otherwise, have a good day, and I will talk to you tomorrow.